Both of us, I'm Raphael, I'm CEO of Alice. This is Kuba, this is our CTO, we're both co-founders. And we came to this because we have a social DeFi company. And basically we're working on exponential social finance. The idea behind what we're trying to solve is that there's trillions of dollars that are being poured into social environmental projects every year, taxes, grants, everything you can think of, and we're not moving the needle fast enough in terms of solving the world's social environmental problems. And one of the main reasons for that is that we're not tracking, there are no incentives to actually track what works and what doesn't. So what we do at Alice is basically build a protocol that turns impact into a financial instrument, because the idea is that if there is some money attached to achieving impact, then people will want to track whether it's being achieved. And the way that works is we have a collateralization system. Essentially what we do is we bring together people who want to pay for impact. So let's say donors, to make it simple, but also taxpayers, conscious consumers or whatever. They want to pay for impact, but only if it happens. So that means that their money is put into a collateral pot that only gets paid out as and when, say, a charity or social organization achieves its goals. But obviously, that organization, that delivery organization, needs the money up front to start running a program. So that's where investors can provide that upfront capital. And we have a tokenization solution that you can see here, which is that when you set up this impact future, so a financial primitive that we're using to run all of this is called an impact future. People can put collateral in, and then there's a tokenization of what we call impact credits that are given to investors. And those give a right on the unlocked collateral as and when it's proven that the charity has achieved its goal. So for example, we're working with St. Mungo's, which is a homelessness charity in the UK. They make promises about how many homeless people they're going to find homes for. They only get the money when a validator says that they've achieved their goals of finding homes for people, but they can sell on the impact credits so that when the collateral is unlocked, it's the investors that get the money. So the charity has the money that it needs up front, the investors have a return on their investment, and the donors are really happy because they know exactly what's been achieved. So that's kind of the basic Alice system. What it creates is just a ton of data, hopefully at scale, because right now we've run 3 live pilots. We have another 10 that are in the pipeline. They're going to go live very soon. But the idea is that you have all these data about all these projects and whether they work or not, and you can start benchmarking and scaling those that are really effective. So where the Gnosis comes in, because we're, do I have the slide here somewhere at the, wait a second. Wait, there we go. We're Gecko grantees. We received a grant to build the binding library. And just to go back, I'm going to explain why we're doing that. So these are some of our partners, first of all. These are the types of charities that we're working with, Cancer Research UK. We've done a bunch of technical integrations as well, Vodafone Foundation, etc. But what we want to do is that if you're investing in a social or environmental project and you're taking on the risk of it not being achieved, so say this delivery organization does not manage to find a home for these homeless people, that's absolutely fine. You can take that risk in isolation. But there might be external factors that affect the ability of the delivery organization to achieve its goals. So what we want to do is use Gnosis prediction markets to allow investors to hedge against those external factors. We also have the idea of allowing beneficiaries in any given social project to be able to use prediction markets to signal whether the program that's supporting them is actually effective or not. But that'll be further down the line. Is everybody familiar with how the prediction markets work and how the conditional tokens work, more or less? Yeah, I'll just do a really quick overview. Then this is kind of the simplest way that we can come up with to explain it. Is basically anybody can create a condition for something that's going to happen. So, for example, do I think that Brexit is going to happen? Yes or no? And you create this condition using the Gnosis protocol, and it spits out these conditional tokens with all the range of possible answers. So is Brexit going to happen? It's either yes or it's going to be no. But the really cool thing about the conditional tokens is you can also split these conditions. So you can have child conditions or nested conditions based on the principal one. And that is, for example, if Brexit happens, will there be a recession? And in that case, the collateral that you're putting into the initial condition, right, because it's a bet on whether it's going to happen or not, and the people who get the right answer get the collateral that's held in the initial condition, you can actually transfer that or split it into the child condition. And that's literally what the conditional tokens allow you to do. So the way that we want to use them is, you have this homelessness project. Is it going to be affected by Brexit happening? Is it going to be affected by something else? And we want to plug that in. So we were looking at that, and essentially it's quite complex to manage all of the abstractions there and to calculate all the different nested positions to do it in an automated way. So I'm going to pass it on to Kuba now, who's going to explain exactly why we set about doing the binding library. If I can manage to get this thing off. There you go.
So when we try to reach our business goal, so building this system for hedging risk for social project, and started integrating with Gnosis conditional tokens, we explored the smart contracts. And I must admit, it's a great piece of engineering. All of credits should go to Alan. Well, I love it. I love it's very minimalistic, very lean, very distilled, and that's why it's super efficient in terms of gas. It's easy to manage security of such a small code base, etc. But the trade-off is that integrating and using smart contract in your dApps could be a bit problematic because there is absolutely no storage for tracking, for convenience in the smart contracts, and all of the low-level calculations are done on hashes, ID calculation, concatenation of that. It's pretty complex structure that needs to be mirrored and mimicked on your client side. And it's, let's say, it's not the most creative, not the most entertaining process for a developer just to mimic all of the smart contracts, Solidity code, inside your dApp. It probably will take you, I don't know, a day or two of hard work. It's very error prone. You can quite easily get into mistake, especially dealing with larger numbers. So having a robust solution to easily connect to Gnosis smart contracts, have a nice interface, could be helpful. And as we get through this painful process, we wanted to give back something to the community as we received the grant from Gnosis. So if you find it helpful, useful, that would be great. Let's say get through the same pain and suffering that we did with the binding library. So in other words, you can focus on really interesting creative tasks, building a nice dApp for your business purpose instead of like doing the boilerplate code. And what can you learn for the next hour? You know, that it's not the best timing. We are competing with the lunch, so we want to promise you something. Instead of skipping the food court, so you should learn how to create conditions, split merge conditions, how to report results, redeem collateral, and how to manage a more complex structure of multiple nested positions. And the main benefits should be basically to fully understand the mechanics of conditional tokens. Not listening to abstract talk, which is hard to grasp, but doing it by yourself, coding, experimenting, creating, merging, splitting, all on your own. And I think it's the best way to fully understand what's going on. And obviously, you can learn how to use a tool that will allow you to build apps quicker. So we prepare a small set of scenarios, kind of interactive, that should present you with some tasks, some tips, some hints in the form of truffle tests to follow and experiment with that. Let me maybe open. So that's the link to the GitHub repo. Obviously, we are going to be around to help you install all of the necessary dependencies, all of the tools. I don't know if you are familiar with using Truffle and Ganache. If somebody is not familiar, I'm happy to go and teach how to install it. And yeah, I think let's start coding. Okay. Let's start coding. That's the piece you should get to. And yeah, I will start by giving you, I don't know, who is going to follow the hands-on coding? Okay. That's fine. Yeah, so let's give you like a few minutes just to download all the stuff, clone repo, install dependencies, and then you can give it a try. And maybe after 5 minutes, I can also like present you the correct answers, or any of you can feel free to go and present the answers. Yeah. So there is a small documentation in the README of the repo that should help you to complete all of the tasks. Okay, and for everyone who is struggling with to compile the original Gnosis contracts, I'm just pointing you to the working configuration of Truffle with a correct Solidity version. That should work. Is it visible? Mm-hmm. Yeah, that would be nice. Yeah. Okay, I think let's maybe try to go together, because some people are not coding, so it could be beneficial for them just to look how it works, to practice. I would try to make it pass. So it's a challenge. Let me get right. So first we need to create the binding library on top of the prediction market system contract. Let me just use okay. Let's try to run the test. Yeah, so we get through the first test. Obviously, there are other ways to initialize HG, not to be null, but the idea is to remain and focus on building prediction, market bindings, and then another task was to create the first condition. It should also be like one-liner. So we use the newly then we pass an ID of the condition. Ideally, it should lead to some external metadata about the condition, but we can pass anything for the test purpose. First condition. Then we point to the oracle that will provide results for this condition and resolve the condition. We use one of the injected test account, but obviously it could be any system, external system, linking to real-world data like Chainlink, Augur. It could be Realtio, anything that you may think of. Yeah. And we define how many possible answers could be given for this condition outcome slot. And that's all. So I hope the interface is intuitive, but any feedback is obviously welcome. And now all of the fun begins. So we put some tokens and we try to do the magic, so split against that condition to create two positions. So let's first get some tokens. Our token is called collateral, which is a simple ERC20 mintable token, so we can easily create funds for the test. Where are we? Let's give our user some tokens. And what's also important, we should allow the prediction market contract to take out on our behalf the tokens whenever we decide to create a position. So we use the approve allowance mechanism of ERC20 tokens and allow and approve PMS a certain amount of tokens to be taken. And now let's try to split. So for the split, we pass a collateral address. So which token are we going to use as a collateral for newly created positions? And what amount of our allowance do we want to use for these positions? Obviously, we can create an approved allowance much higher that we are going to use for the first split, so we get like a credit line for our interactions. What's also interesting, we use the function called full split, which is a little helper. So instead of passing all of the possible positions, in our case it's not very complex because we get only two answers, but for a bigger answer set, it could be a troublesome task just to prepare an array with all of the possible alternatives. So when we use the full split, the library takes care of that. Okay. And what should happen? So we should get two positions. Oh, maybe let's check if it happened first. Okay, it's the fourth test. So what we've done first, we can see that the user balance it's reduced to 0 because actually the prediction market system used the given allowance and all of the tokens are held by the prediction market system contract. So we pass the collateral to the contract. And then we can also check the balance of positions, and every position gets its unique identifier, which we may treat as a kind of token. They use a multi-token standard, 1155 of Ethereum, to handle the scenario when every position gets its unique token that we may further transfer, trade, exchange for some other tokens. Okay. And then let's try, as we split, we may try to merge the newly created position. Let's see what's going to happen. So here we also use a little helper method. So instead of remembering all of the positions, we can call merge all. So all of the positions that had been previously created on that condition are automatically merged. It just saves you a little bit of time for tracking positions. Obviously, there is an alternative way to do it. When we can pass the array of position to be merged. But let's use the shortcut first.
So when we talk about merging conditions, so that we've got a bunch of, like a complete set of outcomes, but we want to kind of cancel them, is that what we're doing?
Yeah, so if we hold all of the possible alternatives, obviously whatever happens, we'll get back the collateral.
Right.
So merging them actually reduces the set of alternatives, the full set of alternatives. Yeah. So we get to the first stage. Let me also comment. So when we perform the merge, automatically the collateral is sent back to the user account. So we see that user has back the 100 tokens that we minted for his account, and the prediction market system contract is currently without any holdings. So yeah, let's maybe spend like 5 minutes for you to work on the second stage, and we can fill in the answers later on. Okay. Okay. Something we don't have. So we don't have a lot of time, so let me try to fill in the answers. So it could be also more interesting to people who do not actively code. Have you managed to get the solution or report?
I managed to get truffle working.
Yeah, so like at the stage there. Anyway, okay, so let me provide the answers and comments. You can do it later on at home, it's not a problem. Okay, so let's first report the results. And we pass the result as an array, indicating which outcome was successful. So that's the message from Oracle. Oracle is calling this, should call this method. So let's mark the first position as a winner and the second one as a loser. So the convention is that you put values per every outcome, and the positive value up to 1 indicates a successful result. So they could be like 2 winners if we get, for example, 3 outcome slots and half for the first outcome slot, half for the second one, and 0 for the third one. Or we can have a draw when we get half and half in this scenario. Yeah, the library also tries to do a nice trick with automatically fetching the Oracle from the available addresses of a provider, so you do not need to switch your context. Okay, now let's try to. Right. Yes. Obviously, we don't have any tests, so it should be fine. And let us try to redeem the collateral from positions. So first we start with a losing position. Okay, so let's go redeem and see what's happened. Let's look at the balances held by user and PMS. Contracts. Okay, that's the question. What should we put here? What do you expect to be a user balance on this position? So a little hint is that it's a losing position. Yeah! Well done. So a losing position should be redeemed to a 0 collateral. And let's check what's going to stay on the prediction market. contract. And your guesses about it? So, yeah. So we send there 100, we get 0, so the expected value should be 100 if there's no money disappearing in the prediction market system. I think quickly. Give it a try. Okay, still works fine. And let's, out of curiosity, do another check. What's the balance of our position tokens after redeeming an unsuccessful position? Because we can either have this, let's say, ghost tokens without any value living in the system, which is not nice, or maybe we just destroy the balance. Let's see how PMS handle that situation. What's wrong? Okay, we haven't passed any user because obviously position is just a token, so we need to put the context whose balance is that. Yeah, so I try to keep the interface for positions as close as possible to the original EC20, so we can easily check the balance without all of the exhausting calculation of indexes. Okay, and the second one, let me just take a shortcut and copy-paste that with a little bit of modification. So right now we are expecting user to get the funds, PMS contract to release the funds, and the position balance should also be 0 because we are redeeming it, so burning the tokens. Okay. So now let's try to do the more interesting example of nested conditions, positions, and moving them around. And yeah, it should be a nice way to discover that the positions are partly fungible. So when you get a nested position and we start with a condition A and then condition B, and if you do the reverse, so start from condition B and go to condition A, actually there should be the same tokens in the system. Okay, how much time have we got? Shall we? 8 minutes. Okay, so let's maybe give you 3 minutes to play around, and then I'll try to fill in, because some people are trying to code, which is great. Oracle? For this, so currently, in the test situation, Oracle is just one of the accounts that is injected, and we automatically take it out of the provider for reporting results. But usually, The prediction market system is abstract away the problem of Oracle. So you just provide an address that could be anything, like an augur system, chaining, reality, or anything that will give you the answer.
And this is implemented in Gnosis or into your library?
Yes, so Gnosis provides the smart contracts, and the library just makes using the smart contract easier. That's why it's called like binding library. As I mentioned, the smart contracts are really low level. So they don't keep a state, they require a lot of calculation of indexes, hashes, etc. to have a correct ID for position, correct ID for condition, and when you start nesting, obviously it's getting harder and harder to track everything. That's why the library gets their own internal state and perform all of the calculations. I can just give you a hint. So the library is also built like we got the utilities for calculating all of the stuff, and obviously we got some object layer for interacting with the contracts. It's still a small library, but we find it really useful, and if it's going to save you a bit of time, yeah, that would be great. This is going too long. Okay, we don't have much time, so let me start to get through this example. So let's first create condition A. Maybe I think it'll be easier. I just let's Okay. The checks are not so necessary, so what we are doing is just repeating the stuff we done before, just creating another condition with two positions. Let me quickly copy paste for the second step. So create the condition B, position B1. B2. Condition B. So it's exactly the same step, just with another condition. So right now we got two conditions and four positions that our user held. And now it's going to be interesting part because we are going to split an existing position to create a nested set of positions. So what should we split? Position A1. Split. position B. Let's try to split half of the tokens. For that, okay, so we created 2 nested positions in our system. I can skip the balance checking. And then let's split part of the first level position B1 against this time condition A. So do something, let's call it a symmetric operation. So we got step position B1, A1, position B1, A2. Position B1. Let's put some other numbers to have a better visibility what's going to happen. So maybe let's perform a check to see how much we got. So, wait. Position B1. Should be. And that's the question. So split 25. Okay. Okay, so let's have something surprising for that. So we just split the position with 25 tokens, but as we see in tests, we got 75 tokens. And that's the magic when, as I mentioned, the positions are fungible. So the position B1, A1 is actually merged together with position A1, B1, and the 50 balance to create like 75. I think we ran out of time. If you want to do it at home, that would be great. You can play, have some fun, learn. There is a cheat sheet, obviously, for you guys with the X branch, with all of the answers and some comments. If you get lost somewhere, and obviously feel free to contact us with some ideas, comments, etc. and the GitHub repo. Thanks a lot.